So in this section, you have seen some videos thus far that have explained symmetry. So symmetry about the x-axis, symmetry about the y-axis, symmetry about the origin. And it has been explained to you algebraically. And also you have seen some videos talk about even and odd functions, and those have been explained to you algebraically as well. What I want to do in this video is show you that also you could do the same thing that you've done algebraically. You can do it from a graphical standpoint in terms of looking at a picture of a graph and determining whether that has symmetry with respect to the x-axis, y-axis, and origin. And more specifically, where you will use this if you take further math classes is you'll use this idea of even, odd, and neither. So you've seen algebraically how to determine whether a function is even. You want to see whether f of negative x is the same thing as f of x. So what you are doing when you're doing that graphically is you're just testing to see whether that function is symmetric with the y-axis or not. So if you have a function that's even, then it will have symmetry with respect to the y-axis. And then when you're testing to see whether a function is odd or not, you're testing to see whether f of negative x is the same thing as negative f of x. If you remember the tests that you do for the origin, you replace both x with negative x and y with negative y. And when you are saying f of negative x is equal to negative f of x, you're doing the exact same thing. You're replacing x with negative x, and then you're also replacing y with negative y. So it's the exact same thing. So odd functions have symmetry with respect to the origin. And every function falls into one of those three categories. Either it's an even function, meaning it has symmetry with respect to the y-axis. It's an odd function, meaning it has symmetry with respect to the origin, or it's neither one of those. So it's one of those three every single time. We don't talk about symmetry with respect to the x-axis for functions, because if you had something that was a graph that was symmetric with respect to the x-axis, it would not be a function. It would not pass the vertical line test. So for functions, we only talk about symmetry with the y-axis, which means that it's even, or symmetry with the origin, which means that it's odd. Otherwise, it's neither. So let's look at these two polynomial functions here. So f of x equal to x to the fourth minus 2x squared and then plus 7. So if I wanted to determine whether that function was even or not, then I could do it algebraically, but also graphically what I could do is I could graph this function in my calculator. So I can come in here to my y equals, and I can type in that function. So let me get rid of my other function from my previous video. And so this would be x raised to the fourth power. Move your cursor over. So x to the fourth minus 2x squared then plus 7. So minus 2x raised to the second power and then plus 7. And then in my standard window, so let me refresh this over here. So then in my standard window, I could graph this function, and I could just visually look at that function and determine, does it have symmetry with respect to the y-axis? Meaning, if I could literally pick this page up pick this screen up off of there and fold it like I would a piece of paper, if I could fold it right on the y-axis and I have a mirror image on the right hand and left hand side, which I do, then I could say that that is an even function. So you just kind of go through the tests. It's going to be one of those three. So if you find that it's even, you can stop. If you find that it's symmetric with respect to the y-axis, you don't need to go any further. So in this situation, I could say that this function is an even function because it does have symmetry with respect to this vertical axis being my y-axis there. So that first one would be an even function. So let's take a look at the bottom one there. Before I move on, let me back up real quick. The one thing you should not get in the habit of doing is looking at these powers and saying, well, yep, that's an even power and that's an even power, so that means it's an even function. Yes, there's probably some connections there that we could explore, but in general, you either need to do the algebraic test, replace x with negative x, and see if you get the same thing. So f of negative x equals f of x. Or graphically look at it and visually tell whether it's an even function or not by whether it has symmetry with respect to the y-axis. My apologies. And so let's look at the bottom one down here. G of x equal x to the third minus 2x plus 4. So if I come back in here and type in that function, so get rid of that. So y equal to x raised to the third power, move your cursor over, and minus 2x and plus 4. So minus 2x and then plus 4. So I'm going to graph this function. If a standard window doesn't work, you could adjust your window, but we're going to be dealing with ones that will work in a standard window. And just going to graph it here. And I'm visually going to look at that and see, does it have symmetry with respect to the y-axis? Well, no. If I folded it there on the y-axis, I would not have a mirror image on the left-hand and right-hand side. So I can eliminate that it is symmetric with respect to the y-axis, so I can eliminate that it's an even function. So the test for odd is algebraically you replace both x with negative x and y with negative y and see if you get the same thing. But graphically, you want to see, does it have symmetry with respect to the origin? Or, I can't do this on the video, I wish I could, but I can't do this on the video, but you have your calculator hopefully sitting there and you've graphed that function. Let me refresh over here, sorry. And you've graphed that function in your calculator. So what you want to do is just kind of take a mental picture or just look at the screen, look at the one that I have graphed for you on the video here, and then take your calculator, graph x to the third minus 2x plus 4, and turn your calculator completely upside down. Or in fancy terms, we rotate it 180 degrees. Basically, you're taking your calculator and turn it upside down. So take the picture that you're looking at on your screen with mine of x to the third minus 2x plus 4, and then take your calculator, turn it 180 degrees, which means turn it upside down. So turn your calculator upside down and see if you're looking at the exact same picture. And you'll not be looking at the exact same picture because whereas this one crosses through the y-axis here at positive 4, if you turn that picture upside down, you'll notice that that one is actually passing through the y-axis down here at negative 4. So they are not the same picture. The picture that I have on the screen and the picture that you would get if you turned your calculator upside down are not the identical same pictures. And if those two pictures are not the same, those two graphs are not the same, then that is not an odd function. So this function is not even because it does not have symmetry with respect to the y-axis. It is not odd because it does not have symmetry with respect to the origin. So in that situation, we would say that that function is neither even nor odd. And for short, we just say neither. So I hope this little short video helps you graphically make those connections between what you've seen in your other videos algebraically with the determining whether a function is even, odd, or neither, and testing for symmetries with respect to the x-axis, y-axis, origin respectively. I hope that this helps kind of help you understand visually what is going on with these graphs.